the clarification was given by theory of relativity, which gave by Einstein. Okay. So there is a concept called time dilation.
Okay.
So
this is what I am interested about. Like,
yeah. So the time will go slowly when it is having higher gravitation, like higher mass. Okay. So this gravity works, we know, like Newton said something, right? And the Einstein come up with this theory of relativity, which changed the whole understanding of physics and the gravity. Like what Einstein is saying, that the space is a kind of fabric. Okay.
Yeah.
So there is a fourth dimension called time, what Einstein said. Okay. So they have, there is a concept called space-time. Okay.
Yes.
Okay. So this gravity works based on this thing. Okay. This fabric of space. Okay. So let us imagine, like everybody gives this same example even you go to YouTube.
Yes.
Okay. Yeah. When it's just like a fabric, if you put some heavier object, it will create a bend in the space.
Yeah.
Right. So this is why if you throw some balls around it, it will orbit through the bend. Okay. So this is how gravity works. There is, the sun is very mass, like it is having greater mass. Okay. So that is why planets around the sun are revolving around it. And even the earth is also having some mass, right? So this is why moon is also orbiting around the earth, because it also creates some curvature in the fabric of space.
Okay. And how does time relate to that?
Okay, so how time relates to that, there is a called time dilation. Okay, so as you are on the earth, there is some gravitation. Because of that, time goes little slower for you.
Yeah.
Okay, and if you ask me that question, like whether the time changes or not in space or something like that, there will be difference, but based on what situation that we are talking.
Okay, so if an object is at rest, it will perceive time differently than the object when it's in motion.
We can't say an object. Maybe we can say an object like like
what
that
person.
Object defines. Like we have to define what's that object.
Okay, so if I'm here on Earth.
Okay.
And my friend goes to Mars.
Okay.
Is it true that he can't age that much as I do? I mean, a little bit of change is there?
Yeah, but you have to, you have to tell the proper situation. Okay. So if you're traveling in space.
No. I'm asking, like, is it true that?
Yeah, it is.
Why does these astronauts age differently than we do, like who are in space?
Okay. So if you have a friend astronaut, who is in space, so if he is traveling in the International Space Station, if he is traveling around in the International Space Station, which goes 28,000 kilometers per hour, so the age will be, the astronaut in the International Space Station will be younger than you. Okay. So if he is not in the International Space Station, if he is, orbiting the Earth with less velocity, let us imagine with less velocity, like you just, the astronaut is just floating in space. So he will age older. If he is traveling in the International Space Station with higher velocity, he will be younger. If he just
because
floating
he's traveling
in space,
faster than the rest of us.
So in time dilation, there are two concepts. So which depends on which is one is relative to gravity. So gravitational time dilation, and there is based on velocity. So when he is just floating in the space, he is not moving with higher velocity. He is just moving in space, just like floating. So the gravitational time dilation will be greater than that velocity time dilation. So the gravity is higher than the velocity there. So that is why the magnitude of gravitation is higher for us. So that is why we is lesser younger than the astronaut who is just floating with lesser velocity in space. If he is traveling in 28,000 kilometers per hour in International Space Station, or if he is going with more speed or near to that, if he is going in higher velocity, he or she, so then they are just younger than us, because the velocity time dilation will be higher. It affects more than the gravitation.
Okay.